All right, so we got a situation where we've got male and female students, large university, and essentially we're looking for a difference. We want to test for a difference in average number of words spoken, or in other words, difference of means between the males and the females. So you can pause the video now if you want to read a little bit more about the context, but we're going to go through our four-step process here, starting with the state. So what are we doing here? Well, we want to make sure that we state in context what we're testing for. So that looks like this. So just to highlight what we've got here, we're running a test for significant difference in the means. Give some context. So mean number of words spoken in a day by male and female students at this university, and then make sure you specify the alpha level. So we've got those things. And then next, what we want to do is identify our parameters. And that looks like this. So we've got mu sub f is the population mean number of words spoken by females, and mu sub m is the population mean number of words spoken by males in a day. Other thing we want to make sure that we include here are null hypothesis and alternative hypothesis. So null hypothesis looks like this. Mu sub f minus mu sub m equals 0, or in other words, there is no difference between the mean number of words of females in a day and the mean number of words spoken by males in a day. And alternative hypothesis looks like this, and that's mainly because they're just looking for a difference. They're not hypothesizing that females speak more than males or males speak more than females on average. So we've got our null hypothesis, our alternative hypothesis, and we're ready to kind of move on into checking our conditions for the test. So we're on to our plan phase here. Our conditions are, number one, are the subjects randomly selected? So we can look up here. We can say random. We've got random samples of 56 male and 56 female students. So males and females are chosen at random. Less than 10%. We've got to look at our sample sizes here. Our sample sizes are 56. So we have to assume there's at least 560 males and females at this college or at this university. And if that's true, then we're good to go. Last one, we want our sample sizes to be greater than 30. So each one of these has to be greater than 30, or if they're not greater than 30, then we could check a box plot or a histogram for normality, or at least no major skew or outliers. Here we've got samples of 56 for each one of them. So these both check out. 56 is greater than or equal to 30. 56 is greater than or equal to 30. We're good to go there. Our sampling distribution of the differences of the mean difference is approximately normal. So on to the do step. Under the do step, we're going to specify what test. So here we're going to be running a two sample t-test. We've got a t-test because we don't know the population standard deviation. And we're going to be testing for the mean difference in words spoken. So there's some information, and because we're running this particular test, we've got to specify a few things. Number one, with the t-test, we want to specify the degrees of freedom. And if we're going to do the calculation by hand, then our degrees of freedom would be whichever sample is smaller, it would be one less than the smallest sample size. Here, both our sample sizes are 56. So our degrees of freedom would be 55 if we're going to calculate it by hand. We're not going to calculate it by hand. We're going to use our TI Inspire. The other thing that we need is a T statistic, and we're going to get that from the Inspire as well. So let's go ahead and jump over to the calculator. We'll figure out how many degrees of freedom our calculator says to use and the T statistic based on running this test. So we go over to our Inspire, we go to menu, statistics. We're doing a stat test here. And this test in particular is asking for, this test, here we go, is asking for a two sample t-test. We're going to enter our stats. And this is the info that we need. So I'll go ahead and enter that. So we got that information entered. Our alternative is that they are not equal. We're not testing a one-tailed, we're testing a two-tailed, so we're good here. and we don't want to pool our variances. We want to test this as if the variances were separate. So here's what the calc spits out. First of all, our t statistic, we got to make sure that we make note of this, is negative 0.248. We're going to use our calculator to report that, and then our degrees of freedom. Those are the two things that we need in order to finish up this do step. So let's go ahead and report those. And the other important thing we need is the p-value here. So the p-value of 0.804, and hopefully these two values kind of jump off the page to you. This is a really low, or a really, I guess, t statistic that's close to zero, which should mean a particular thing to you. And then the p-value, really high p-value here, kind of should point you in one direction. And those are really the two things that are two biggest things, along with the degrees of freedom being the third, that are of interest here that our calculator spits out. So let's go ahead and go back and make our conclusion based on this info. So you can see under this do step, we did a lot of stuff under this step, but these are really the relevant things that we have to report. We got to report what kind of test that we're doing. We have to report the degrees of freedom and the t statistic for that particular test, and then run the test and report your p-value, and that's pretty much it for the do. And then after that, we make our conclusion based on that p-value and what tests we're running in the alpha level and all that other good stuff. So let's go ahead and make that conclusion. So with a p-value of 0.804, we failed to reject H naught at the alpha equal 0.05 level. Notice I reported the p-value, compared it to the alpha level, and made a decision on my null hypothesis based on that comparison. And then the rest is just context. What does that mean within the context of this problem? So here's what that looks like. So I'm kind of running out of room here. I squeezed it in, but we find there's insufficient evidence of a significant difference in words spoken in a given day by male and female students at this university.